And we are on chapter 4, physics for grade 9 and 10, force and motion. Our topic for today is motion of bodies connected by a string passing over a frictionless pulley. In my previous lesson in 4a, I did derive the equation and got the value of acceleration and tension when bodies are moving vertically, one upward and one downward. Today in 4b, we are going to discuss about two bodies, one moving vertically while the other moving horizontally. Now here you can see the figure that let's consider this to be a table over here and a pulley attached on the other end, and this body is moving horizontally and this one A is moving vertically. Body A is moving vertically and B is moving horizontally. Now let's discuss about this body which is moving vertically. So for body moving vertically, you can see that the tension, okay, is over here and the weight is acting downward. The weight is greater than the tension. Okay, so we can say that W1 is greater than tension. T. So if you see that W1 is greater than T, the tension acting on this string, so the total net force will be W1 minus T is equals to F1, because we are considering 1 to be the body moving vertically downwards and the one which is moving horizontally as 2. Yeah, now we replace F with, we know that according to Newton's second law of motion, F is equals to ma. So let's replace this by ma. So this will be m1a and W is equal to mg. So I can write it down as m1g minus t. Okay, let's consider this as the first equation. Now for body which is moving horizontally, for body moving horizontally, there are forces acting on it. According to Newton's third law of motion, you can see that the force, the absence of an body at rest will remain at rest, and you could see that the action and reaction are always equal but opposite, the reacting force and the. So if it's at stationary position, so then we can say that that W is equals to tension over here, T. Okay, so I can just write it down over here as the tension that is acting on it, and if the body is accelerating, okay, it's moving. The body is moving, that is accelerating, then obviously we can say that the tension is equals to force. And since we are discussing the body 2B, so that would be force is equals to tension. Okay. Okay. The reacting force and the weight will cancel out if it's not moving, but otherwise if it's an accelerating, then we can say that F2 is equals to T, and according to again Newton's second law of motion, when you put the value of F, that would give you ma. So let's call it ma. This is the second equation. Now when you add the two equations, right, so what do we get? m1a plus m2a is equals to m1g minus t plus t. This is when we add equation 1 and 2. Now minus t and plus t will cancel out. Here we can take acceleration common, so we'll get m1 plus m2 is equals to m1g, or in other words, when you move this on the other side, so this is multiplied, when it goes here it will be divided, so I can say that a is equals to m1 over m1 plus m2 the whole g. G is your acceleration to gravity. Hence we have just proved acceleration. So now in order to get tension, what do? To find the value of t, we substitute the value of a, acceleration, from this equation in any one of these two equations. Okay, let's substitute in equation 2. So in equation 2 we know that m2a is equals to t, so I can write it down as t is equals to m2, and I'm replacing it with value of a, which is m1 upon m1 plus m2g. Hence we get tension T is equals to m1 times m2 over m1 plus m2 the whole g. There you are. So we have just proved that T is equals to the product of two masses m1 m2 over the sum of two masses m1 plus m2g. I hope it's clear to you all. So with this we conclude the two cases. The first case, if you remember, in lesson 4a, we discussed about two bodies moving vertically, one upward, one downward, and this is case 2. In lesson 4b, we just discussed about two bodies, one moving vertically and the other moving horizontally. And we calculate the acceleration and tension in both the cases. Thank you very much. I hope to see you in the next lesson. Take care. God bless.